we will be discussing about step-by-step advanced Python pandas feature, and at last we will be doing a data cleaning project, and I will show you the live demo on what are the steps that we need to clean our data. So at last, after going through the step-by-step advanced Python pandas feature, I will be showing you a demo on how do we clean our data, and it's gonna be a data cleaning project. So let's start. I have imported my pandas, and this is to enlarge my screen. You can even play with it and can set to 80% or whatever you like. So I am setting 100% so that we can have a clear resolution. So at this time I have imported my invoice data. So let's quickly look at invoice data. Let's look at my header. So we have order ID, meal ID, participants, and what type of meal they have taken, whether it's a breakfast time or dinner or lunch. So, or even we have a boolean values. So I'm going to discussing with you is data type and conversions. So there are 7 data types in pandas. So first one is object, and then integer, float, boolean, datetime, time delta, and category. So what we need to do, the initial step while we do analysis is pandas by default it's the data type based on based on the file. The pandas automatically set the data type. So uh, once my file is imported, I can check my data type. So order ID is object, date field is also object, and we know that the object is data field that is specified by string. So date, we need to convert my date value to date format, meal ID to ID, date of meal. This also needs to be converted into my date format, and type of meal. This is my category. What is category? Categories are the values that take one out of a limited number of available option. It's like categorizing some fields. So we can see that in while looking at top hit rows, it has meals has breakfast, lunch, or dinner. We even can set and look at the value. So type of meal is pounds. So you can see we have 3 categories of type of meal. However, this type is being assigned to being assigned as object. So we need to be careful with these values, and we need to set appropriate data types. So we know the pandas has 7 data types, and I'm going to be using, there are 2 methods to convert the data types. 2 standard methods are by using astype, and another is using 2 numeric and 2 datetime. I'm going to be showing you the difference of both. So we know that our date field needs to be in date format. So this needs to be in date format. However, it has been, pandas recognize it as an object. So let's first convert it into date. So it accept date time 64. So this is the data type that the pandas accept. So we need to give this to as date time 64. And we know that our type of meal, this is a category field, category data type. So we need to convert this into category. And our meal price is to be integer. So now if I take my type. So we can say that the date field is has data type dates. It has category. This has boolean, integer. So we can now say that the date field has been populated. However, date of meet, we still see this as an object. Why we see this as an object is because uh, this has been, the date format is plus 02. If we convert this in let's say date format, mm, let's put it in itself. So this throws me an error, and it says that it cannot be converted into datetime 64 unless we specify our UTC equals true. And this can be done because this is in the time date format is in UTC. So we need to convert this and set this to UTC as true. But this is not achievable through as type function. For this, we need to take help of PD underscore to date format, and I'm going to show you the difference. Why we need why PD underscore to date format is more smarter than as type. So this was my result where we converted our date format using as type function. However, date of mail is still being used as object. We will be converting this into date time. I will show you how we do that. So this was how we do on the basis of as type function. Now I'm going to be showing you the use cases of using to numeric. And but before that, I'm gonna be showing you one more tricks of the useful of the cases where we converted the type into date format, category, and boolean. So what will be the main uses is if we convert this in a specific format, then if we select, we can even select the types, and if we include equals number, and show me all the numerical values that we have in our data set. So in this data frame, we have only one numerical value, so it is showing only one. But imagine if we are working in a software company, we can have 100 to 100 columns in one data frame. So this command will definitely help us to distinguish between the categorical numerical field. So in this way, we can convert and check our field, whether it's category or integer. We can even specify that. Oh, one mistake is being made here. This is in date format. So yeah. So yeah. So in this way, we can, if we include here, we can check whether our how many category field we have in our data frame, how many objects we have in our data frame. We can check by using this shortcut command. So let's jump over using to true numeric and true datetime value. So let's say, for example, uh, as we know our now we know the types. If we do the types, we have our price field is meal price is in integer, right? So if I include string value, let's say for example, if I do loc in specific field, let's say suppose for example 4612, or in any, we have meal price. Let's say in this particular row, have records till 50,000. So I have used random number here. So let's say if I'm here, or let's say in another 620, if I do any field, do anything. So even this field is we know that this field is integer. My meal price is integer. It's now been converted into meal price is converted into, but we have converted our meal price into integer, and I have set my rows for meal price to, I can even set my rows to string field. Even this field is integer, I can set my values for this field as string. So how can I find out how many strings we have in this field is? So I'm gonna use prices. I'm gonna use my lambda function. Value that counts. So we see that we have 50,015 integer and two string field. So even this field is integer, we can set our rows for this field as string. So in this case, the value is both integer and string. As underscore type will not convert it into, suppose if we now use this is wrong. This one. So this is my string field. So I have inserted two rows. So we have two string and 50,015 integer field. Now if I try to set this as will not recognize it, because we have two string field. So in this case, in this scenario, the in this scenario we can use two numeric, pd underscore two numeric. This comes into handy. So let's do a bit of more analysis, like how many cases we have. Let's see two string fields. So how can we view our string fields is using lambda function dot apply. Okay. So yeah, we have assigned two rows to a string field. We can view this as by setting each instance to str. If we need to view integer, how many integer we have in this field, we can view by using lambda operation. So how we can handle these string cases if we have string and integer in both numerical field, as we saw that as underscore type does not work in this case. So in this case, to underscore numeric comes into handy. We can use pt.to underscore numeric. So you can set the variables equals, so yeah, course. What this does is it converts my two string field into AND cases. So if we check, you can see two NAND cases. Let's view the complete record. I need to restart it once again. Sorry for that. So yeah, here we can see two NAND cases. So error equals courses assign two string values that we have assigned here to NAND cases. So how we handle such NAND cases? We cannot simply drop those value. So what we will do is we're gonna fill it with a median of our price value. So what I will do is I will fill this with fillna, and I will take median. So I take this now. So we have zero cases. This is even the way how we impute null cases. We analyze data, and on the basis of our analysis we set it to take median or some other values. So this is how we can see numeric comes into to underscore numeric comes into handy, where we have both integer and string field in one particular column. So here we find out we knew the difference between both the field. So let's convert. Now we can convert this into astype as in integer. Yeah. Now I will show you how we're gonna handle what to underscore date time does. It handles several date format like 8 dash 1. So we can see how date format handles any date values. We even can change it to a specific date format. For example, this converts it into percentage D, Y, and M. And we even have uh, one thing we can do is, suppose if we have a string field in my numerical value. So what I can do is, if I give exact equals false, then get my value. So this even comes into handy if we include exact equals false. It converts the value. It looks in the string and converts the value into in a specific date format. So now we're gonna see how we can use our three different accessor dt, or so invoices. If it invoices it not dt not date, so it converts it into date format. Likewise here, puts it into here, puts it into days. Then you can get the name. So even if we need month name, we can even specify month here. If any day of the month, we can use days underscore in underscore month. Mm, that's okay. So I have shared you a link here. So here we have all the date formats that we can play around and convert it to our specific format. We can choose, we can play with any date format. We can have more detailed information there. And we even can use underscore month underscore touchdown. It gives boolean value, so it tells all the start of the month data. So we can, likewise we can play with end of month, is quarter started or ended. We can play with all these functions. Likewise, even we can uh, retrieve specific months or day using underscore five, it. We can even retrieve two underscore, or we can use period and specify here quarter or weekly, and can get the weekly data. So these things we can play around with date field. Likewise, using str, we can even convert it into lower cases or in this window lower cases, will do upper cases and title will do proper cases. We can even adjust our field value for simply using L. Just if we give suppose width equals 15, adjust on the left side. Same likewise, if we give R, we adjust on the right side. Likewise, if we give center, and adjust in between the center. And another thing is, if we use Z fill, it will make a consistent length of 15. So this even comes into handy when we have a numerical field and we need to make a consistent length. We can simply use Z fill and define the width. Likewise, we can even use start with, for example, of mil dot str contains suppose ast to check. So it shows me all the type of meal that has values ast. We can even use int with also. So this is how we can check all using start with, end with, and contains. Likewise, we can use .str dot swap cases. Then swap the first word, and even use repeat. Suppose, for example, I'll repeat to repeat my word 2 times. So cat even plays a handy role if we define our data type as category. So for example, suppose we have defined our categories, a type of meal as categories, so we can see what values we have in category field. We can quickly convert our category to numerical field by simply using quotes. We can even reorder our category field by using reorders. Just reorder categories. Specify our categories. For example, if you need to have first as lunch, second field as first, third field as dinner, order. Now, if we have 3 data frames, for example, how we gonna be adding this 3 data frame? We usually use Concat function to add 3 rows, 3 data frames on the condition that all the data frames have equal number of columns. So here we have, so for example, let's let's convert our invoice date to let's take year and we have 5 years of data. Let's split that in a particular data frame. 2013, 14. So 15, 16, 17, 18. So I have used copy because we are creating a copy of invoices based on each year. So now, in order to concat these data frame, we use concat function. We can specify by default it adds all the columns. Spelling concat. By default it concats all the data based on it opens all the rows. For example, we have three data frame. It simply opens all the rows by matching my column. So in 2014 we have 4, 5, 6, 7, 8, 9 columns. So all data frame has 9 columns, and it simply merges our data. It simply adds our data. So if we how many data are for 2014, how many data are inserted for 2015, so what we can do is simply set a key value and can give the name. For example, the comma keys equals 14 5 data 17 18 and it means as here is index. So what this does is it splits my all combination, like how many data are inserted from 2014, 15, 16. We can simply distinguish based on this field, this based on this key. We can find out how many rows are inserted. So this was vertical stacking. In horizontal stacking, we simply add the columns. So if you need to add these columns, simply we can use this, and we need to specify our index axis equals 1. This axis equals 1 appends on the basis of columns, and by default it appends on the basis of rows. So we can see here in an order ID is being added and so on. This is how we axis equals when we do horizontal stacking. So now let's merge two more data set, my order data and sales data. So order data is this, and we know our invoices have similarities. Like now what we are doing is we are applying merge so that we can join invoices and my order data. So while looking at these two data frame, we see order ID, date, and company ID being matched. So if we simply do a merge, then suppose for example if we do pd dot merge order underscore data comma invoices, so it it joins on basis of all the available field match. For example, it looks at the match is on the basis of order ID, date, so it looks at all probable fields and perform a match. So by default, if we don't give any condition, simply look at all possible field name that matches between both tables and perform a match. However, we can even specify here, for example, on. Now what this does is do a match only based on my order ID field. So it does match only based on order ID field. For example, what if we have cases where we don't have match between these two columns, if no columns are matching between invoices and order data. In case of columns not being matched, we can specify my left and right columns and can do a join. So how is this done is merge. Suppose my suppose if I need to rename, if I rename my invoice column, for example, let's say if I rename my order ID, I have ID. What I can use is left underscore on equals order ID and right equals on equals. Now I have changed that to new ID. And even you can specify here how equals inner or outer, or which join we are using. It is not matched. So order ID is not correct. Yep. Now we can use even how equals inner. So this will do on basis of inner, outer, left. This is how we merge. We do a join on the basis of two table. Now how we can use my data as both lookups. Suppose for example, this is my cell string data frame. Order data. So I want to know the company name, the sales representative of this company name. So how can I merge my sales? For example, in sales team we have company name and sales representative. In order data we don't have sales representative, but we know that the company name are matching. So I want to pull sales representative in order data by doing a lookup. How can I do is example dot set index. So company name sales. So what this does is it creates a lookup between company name and sales representative. Now we can apply this lookup in this data frame. Suppose if I want to create my new column, sales representative, order data, name, bracket. So if you can see my lookup now, we have all the representatives. So this is really handy when we don't have data in another column, and without making a join, if we can simply create a lookup table between this and sales team and order data, we can simply use a map and specify my lookup and can pull the information from sales team. So this is how we can apply lookup. This really comes into handy when we work in real industry. So now I'm going to show you how we transpose uh, my data frame simply by using the T. Simply the transpose. Now I'm going to show you how the mate work. So, so just bear with me. I'm going to show you what I'm doing. For instance, access v 0. Sure. Mhm. So what we have done is we have imputed our values. For example, here what I did is for type of mail, I included my values for the prices. Like I have set my transposed my type of mail field and included the price of meal. However, for dinner and lunch, I have for this line dinner and lunch it will be zero point 0.0. So what I did is simply uh, looked for type of meal and did a mutation for invoice of meal price. So now what we can do is let's delete our two fields. One is of meal. Another is now we have this two field. Now we can see that we have imputed our values. Now what milt does is, uh, this frame. Let's go and see. Yes. So what it does is it groups on the basis of this field, and it takes one variable and assign the values of this three field in this variable, and what will be the value name that will be assigned to this field. So this will be my this three field which I want to convert into rows, and I'm gonna be specifying the name as type of mill, and I'm gonna be using the values of this field into then giving the new name, and that will be expenses, and I'm going to be adding the values of this in this field. So what mill does is it transposes all the columns into row based on my specific field. This is my three field which I want to pivot. I want to transpose, and it groups on the basis of this field, and it transposes this field into one particular column type of meal. So type of meal will have three values, and the price of breakfast, dinner, and lunch will be set into another field, which is expenses. So this is where the milt comes into handy, where we want to transpose our columns into rows based on a particular field. Now let's talk about pivot. values is in price repeated function is function. Yes. This is my non-file. So now we saw that how it again transposed my rows into column. It set my index. I set my index as company ID, and on the basis of company ID, it transposed my column. My column name is type of mill, and the value is mill price, and it took the mean of mill price, and it set on and it transposed on the basis of company ID, transposed my uh, column, which is type of mill, from rows to column, and it took the average mean of mill price. So this is how pivot works. Now let's jump into stack and non-stack. Maybe. So on stack first. So what Unstack does is simply it looks at last column. My last column is heroes adjustment, and it transpose to columns. So this was my initial table. So what it did is it looked for last column heroes under adjustment, and it simply transpose my um, the value of heroes adjustment true and false, and it's simply transposed. So it when we do group by uh, and specify my columns, it simply look at last field and do a transpose by taking the mean of mill price. So this is how the unstacking work. So if we need to unstack based on any particular field, we can even specify that. Suppose, for example, if we use an unstack package label equals of, so it's simply on to unstack based on type of mill field. So now let's test for stacking. And suppose application. Um, so it's on the price. It's it's now we have I have taken max and min. Now if I simply do stack, so simply converts my column into rows. So this is how stack work. And that's it for this tutorial. Hope you have learned a lot. In next tutorial, I'm going to be showing you a live demo of what things needs to be considered while doing a data cleaning project, and the things that we need to consider while working on cleaning data. So that I will cover in my next tutorial. Hopefully you have enjoyed the video and learned a lot. So that's it for today. Thank you so much.